Hello everyone. Today we are going to continue Kepler's laws. We talked about Kepler's first and second law. Today we are going to study Kepler's third law. Okay. What is Kepler's third law? Kepler said that the ratio of the squares of the periods of any two planets, let's say that I have Earth and Mars, okay? He said that the period of Earth squared over period of Mars squared, so T1 refers to the period of Earth and T2 refers to the period of Mars. What is the period? I will remind you. So period is the time the planet takes to make one complete revolution, okay? He said that this ratio of the period of one planet squared divided by the period of any other planet squared is equal to R1 cubed divided by R2 cubed. What is R? So R, we defined it also as the radius, or we say, girls, the distance from the sun to the planet. The distance from the sun to the planet. So let's say here the sun is at the center and the earth is orbiting the sun in elliptical path, and Mars also orbiting the sun in elliptical path. Now girls, you will tell me that, teacher, we said the sun, it's not at the center, it's at one of the foci. Okay, that's correct. First law of Kepler states that all planets move in elliptical orbit around the sun, not in circular orbit. But all the planets actually, they move in elliptical orbit, but these ellipses are not very squashed. The circles are not very squashed. It's nearly circular path. So you will see here in our work today that we will consider, okay, that our path is nearly circular in order to be able to do all the measurements. Okay. Now this is the law. We will memorize it as it is. Okay. So the ratio of the period of any planet divided by the period of any other planet squared is equal to R1 cubed divided by R2 cubed. What is it? So what is R1? R1, it is the distance from the sun to the first planet, let's say Earth, and R2, it is the distance from the sun to the second planet that we are talking about, R2. Okay? What is T1? T1, it's the time the Earth takes to make one complete revolution. T2, it's the time Mars takes to do one complete revolution. Okay? Now, we want to prove this. You will see that we can prove it using Newton's law of universal gravitation. It's not hard, but please, girls, pay attention with me. So let's say again that the sun is at the middle and the earth is orbiting it. According to Newton's law of universal gravitation, okay, we know that Fg is equal to what? You remember? It's Gm1 m2 over r squared. Okay. Now we can show, girls, mathematically that Kepler's third law, the one I told you about now, T1 squared over T2 squared equals R1 cubed over R2 cubed, can be derived from Newton's law of universal gravitation. How? We will recall first that this Fg, it is actually the centripetal force, right? We said every object in circular path, or here it is nearly circular path, okay? Nearly circular. So we are considering it here circular in order to do our equations. We said that the centripetal force here, it's the FG. We explained this in the first section in circular motion and gravitation. So centripetal force is what? Keeping here the Earth on its orbit around the sun, right? So what is it? It's centripetal force here. It's the gravitational force exerted by the sun on the Earth. So it's correct to say Fg equals Fc. Fg, we learned in section number 2, Newton's law of universal gravitation, that Fg is equal to this amount. So G, M, I will replace 1 by P for planets and 2 S for the sun, because these are our two objects now, Earth orbiting sun, divided by R squared equals, who can remember what is the equation of centripetal force you learned in the first section? We learned in the first section that the centripetal force is equal to mv squared over r. The centripetal force of an orbiting object is equal to the mass of this object times v squared over r. So it is the mass, centripetal force on the Earth, it is the mass of the Earth, which is our planet, times v squared over r. See now, mass planet here on this side and mass planet on this side. What can we do? They can cross them. They can cancel each other. Okay? What else? I have here r squared and here r. So, for sure this r can cancel one of these, because this r times r, it's r squared. So, I will rewrite my equation now. So, my equation now, it's G, mass of the sun, divided by r, only one r got cancelled by this, okay, equals v squared. See, like I got an equation for v squared. Okay, so now simply I can get an equation for v. What is v if I want v? So I just make square root for this one and square root for this one. So it's a square root gm mass of the sun here divided by r. Okay, so this is the speed of what? This is the speed of the Earth. So this is the speed of the planet, which is in orbit around the sun. So this equation we have to memorize it. M, which is in this equation, always it stands for, look, m sun, right? So it stands for the mass of the object being orbited. Okay? So we have to memorize now this one. I have here another equation, and I want to show you girls, I want to prove the third law of Kepler. We will prove it together. Okay, so I will repeat. Fg, we said it's equal to Fc, and we got that here G, mass of the planet, mass of sun over r squared is equal to m of the planet times v squared over r, and we crossed this and one of these. We got a gms, which is the object being orbited, the object at the center, over r equals v squared. Now I want to show t in my work, okay, because I want to prove third law of Kepler. What is the third law of Kepler? I will write it here on the side. T1 squared over T2 squared equals R1 cubed over R2 cubed, okay? So I want to show T in my work. How to show it? See, girls, we know that the Earth here is going in nearly circular path, and we assume that it is circle. It is perfect circle. Okay, now V, it is, we learned, it's D over T from grade 7. Okay, so the Earth here, the sun is at the middle, and the Earth going, we said, like in a circle around it. So what is the distance? The distance here of this circular orbit, what is it? It is the circumference of the orbit, right or no? And you know in math that the circumference is equal to what? 2 pi r. Okay, what is t now? The time taken by the Earth. The time taken by the Earth to complete this revolution is the period. So over t period. Okay, so v equals 2 pi r over period. By substituting this one now here, okay, we will see what will happen. See. Okay, so G M S M sun over R equals V. Instead of V, what will I put now? I will put the equation of V. So 2 pi R over T, and don't forget the square. I will raise it to the power of 2. Okay, GMS, only math, over R. So 2 squared is 4. Pi squared is pi squared. R squared. This is square for V, all of it. Okay, so T squared. Okay, let's make it simpler. How to make it simpler? By making cross multiplication. Okay, so G M S times T squared, this multiplied by this, equals 4 pi squared r squared multiplied by r will give us what, girls? R cubed. Okay, so now if I want to get period t squared, this one alone, so I want this. So how to get rid of this one? By dividing on it both sides. So 4 pi squared r cubed over, this is cubed, over g m. Okay, I will rewrite the equation here. So we got that t squared is equal to 4 pi squared r cubed over g m s, the sun. Okay, so this is the general equation of period. Okay, so this is the equation of period squared. For sure, from it we can get period. You will see later. Okay, how? But now I want to prove the third law of Kepler. Third law. Okay. So girls, let's say, what is the third law? We said it's t1 squared over t2 squared equals r1 cubed over r2 cubed. Okay, we can use lowercase r. Now, girls, let's say that we have Earth and Mars, as we said earlier, 2 planets. Okay, so t1 squared for Earth and t2 squared for Mars. So t1 squared from this equation, it's 4 pi squared r1 cubed over gms. Okay, type t2 squared, the same thing. We are using the equation 4 pi squared r cubed over gms for t squared. Okay, so replace it here. It's also 4 pi squared r2. It stands for radius of, or the distance between Sun and Mars, r cubed divided by gms. So some math here. So for sure this 4 pi squared will cancel this, and gms here cancel this. So we will get what? t1 squared over t2 squared equals r1 cubed over r2 cubed. So this is Kepler's third law. Okay, so third law of Kepler was supported by Newton's law of universal gravitation. We will continue about the last part of Kepler's third law. Okay, we said, girls, that t squared is equal to 4 pi squared over mass of the central object, which is the sun, for example, times radius cubed. Okay, where did we get this equation from? We got it from the fact that the centripetal force is equal to gravitational force exerted by the sun, for example, on any planet that's orbiting the sun. Okay, so from this equation we can see that t squared is proportional to what? To r cubed. Why so this symbol, it stands for proportional. Okay, why it's proportional to r squared, r cubed only, and not this? Because this one, this quantity, girls, if you notice, it's all made of constant things. 4 constant, doesn't change. Pi constant. G constant number. If you remember, it is 6.6 times 7 times 10 to the power of negative 11, so it doesn't change. And the mass of the sun also is a constant number, so this quantity is a constant, so that it doesn't affect actually the period, the orbital period, but instead the radius, or we call it, so r, it's the mean distance. What means the mean distance? It means the distance from the sun to the orbiting planet. Okay, to the planet. So this amount we can, girls, therefore call it the constant of proportionality. So there, since t squared is proportional to r cubed, so this is the constant of proportionality that relates them. Constant of proportionality is 4 pi squared over gms. Okay, so girls, here we can write the third law of Kepler as t squared proportional to r cubed, or in the same way we wrote it yesterday, t1 squared over t2 squared is equal to r1 cubed over r2 cubed. The ratio of orbital periods of any two planets squared is equal to the ratio of their mean distances cubed. Okay, so this is the third law. We can write it in this way or in this way. Okay. And girls, also yesterday we got that using this fact, Fg equals Fc, we got the equation for V, and we said V is equal to G square root Gm over R. Okay, so this is this equation. We are going to use it in practice. We have to memorize it. And now we want an equation for the orbital period. It's very simple because already we got the period squared. So in order to get period only from period squared, we will do square root for this, all of it. Okay, so t squared, it is 4 pi squared r cubed over gm, r cubed over gm. Make square root for this and square root for this. We are going to get t equals square root of 4 is 2. Square root of pi squared is pi. Okay, so 4 pi squared, I can, what, girls, take it out of the root, but the rest I will keep them inside the root. So r cubed over gm. This is the other equation that we are going also to use in this section.